been doing this since 1980. That's where I learned most everything from people I've worked with. This is basically about PI counts. Oops, how's that? All right, I got it. A PI count is a preliminary incubation test. It's not complicated. It's just we take the milk sample in a lab and put it in an incubator at 56 degrees, stress it for 18 hours, and then take it out and run a standard plate count on it. I like, when I'm looking and working on a farm, I like to run a standard plate count and then run the PI on the same milk, and it gives you an indication of whether you're looking for cleaning processes or if you're looking for a cow problem. Got lost here. This is a quality test. When you get your lab results and you're looking at them, the line on the left is somatic cell, and these are real numbers. This is from a farm that was eat up with Staph aureus, and all his somatic cells are 1 million or plus. The middle column is standard plate counts, and then the PI counts are over on the right. And you'll notice that all the standard plate counts are the same or maybe a little bit higher than the PI counts. The bugs that make PIs and the bugs that make mastitis don't live. The mastitis bugs don't live when you incubate it. So most of the time, if you get somebody's got these high counts, you should be looking at a cow on this instance instead of for PI problems. PIs do not come out of the cow. They're the results of poor sanitation, poor cooling, cow prep, or milking wet cows. And a very important thing to remember is PI spores are airborne. They will float around in your system, in your vacuum system, and back and forth. This is a picture of a fresh cow tail out of Kentucky. Our girl up there found this. It's a better picture than the one I had. That's actually about 1.5 inches of clabber around the top of that bucket. And this is the lid that went on top of the bucket. You think about talking about the spores floating around. This bucket, you hook your milker to it, and then you plug it into your low line. You suck all those spores right into your low line. You can have a perfect clean system, cooling's good, but a bucket like this will make your PI count be up in the millions. And this is just another example. This is the top of a trap. And I'll point out here that a lot of the old systems were not designed to keep milk out of the vacuum side of them. So you have more problems with old systems than you do modern systems. But you see just a little bit of milk on the top of that. That's the bucket off of it. This is the whole system. And this guy never has a PI over 5,000. See how clean his jar is and everything? And I want to make a point here that how did that milk get over into the trap? When you run that first rinse cycle, that's milky water. And in these old systems, that hits this receiver so fast that it sloshes over and comes down in the trap. And then it dries out in there. This guy's usually below 5,000, like I said. He ran 40,000, and that's a high count for him. And that was all we could find in the whole system. Cleaned that up and it went back below 5. This is what happens when you don't wash. That actually looks like Jello in the bottom of that, and it's got green tint to it. I sent that picture to the lab, and they said he must be Irish. So anyhow, this is what happens. The hired help decided they wouldn't milk for 3 or 4 days. Our machine only read 4 million. And his standard plate and his PI were both 4 million. This is the most important slide I've got. To clean a milking system, it takes all 4 of these items. You've got to have water, you've got to have chemical or detergents, you've got to have physical contact of those water and chemicals to the surface, and the temperature of the water has to be right. It takes all 4 of them. If one of them's out of whack, when you're looking for a problem, you may discover it if you can figure out which one of those is not working. Like I said, PIs love 50 to 60 degrees, so There is a season for PIs. It's in the spring when your air temperature outside is 50 to 60 degrees. If you've got any part of your system that's not good and clean, and the air temperature is 50, those bugs are growing in there. And another thing about PIs, at 50 degrees, they double every 20 minutes. So if you think about an hour has 320 minutes in it, and you started with 10,000, it'll go to 20 to 40 to 80,000 in an hour. The second hour, it will go 160, 320, 640, and if it gets in the third hour, you're going to be up in the millions. So always keep that in mind. If a farmer calls you and a tank's off, how hot was it? Well, it was only 70. How long was it 70? You know, so you can kind of guesstimate how high the milk in that tank is if you're not going to be able to get it sampled before you pick it up. But once it gets above 50, when it's at 70, it's faster than every 20 minutes. Tank cooling is the same effect, slow cooling for any different reason. But when I go in a barn, I look at the fresh cow pails, but I look at traps is usually the first place I look for a PI. I look in the vacuum reserve tank. I look at how they're milking the udder prep. You know, milking wet cows, we call that magic water when you draw off the teats and the cows are wet, and then you put the machine on, that water runs down on those teats, and we call that magic water because it'll be at the top of the inflation, and then it disappears like magic. And that's just dirty manure-coated water that is the right kind of bugs we're looking for. And another thing about washcloths, if you're using them and washing them, washing does not kill the bugs. You've got to put them in a dryer at 120 degrees for at least 12 minutes to kill the bugs in those cloths. So if you're just washing them and bringing them back and using them again, you're just spreading more germs from one cow to another. Milk tanks are designed to cool in 4 milkings. If you're filling up every day, a tank filling it up every day, you're asking it to perform twice as much as what it was designed to do. So you tend to have poor, slow cooling, we call it. You need to have a pre-cooler or a tube cooler. This is another, so a lot of your old tanks didn't have an agitator that automatically comes on every 20 minutes. I've gone in barns with those old flat top tanks and the milk's just sitting there. You stick your thermometer in, it's 60 degrees. You turn the agitator on and let it stir up, and it was 46 degrees. You know, the cold goes down and heat comes up. So that milk sits there waiting for the temperature of the whole tank to get high enough to make the probe, which is underneath the bottom of the tank, turn the compressor on and spin it. So it probably not a lot of those tanks left, but we see them from time to time. Then this is just the opposite. This is a guy that's about that. Well, he's not here with us anymore, but that was one milking, and he was still in a big tank, and that's a solid sheet of ice. That milk is just froze solid because the agitator didn't spin it when he was milking. He got through. Now the probe underneath that ice thinks that the milk's 32 degrees, which it is, but when you go to the second milking, you put 98 degree milk on top of that ice. That compressor is not going to come on until you melt this ice with that hot milk. And this situation, the bacteria just explodes immediately. This is out the roof. Milk lines. This is an air injector. And I'll point out that all systems, these old systems and the new systems, they're all alike except they're different. This is an air injector on an old system. And what it does, the top line is a milk line. And when you're running your wash water around your system, the water will just run in the bottom of that line. So your air injector opens up and it'll suck air easier than it pulls water. So the water, that air comes in and pushes the water and makes that wave right there. And that's what washes the top of your pipeline. So if you have leaks in your pipeline or some other factor, what I use as an example, probably the Jetta cup on this claw is leaking. So it sucks air in here And when that air gets in the pipe, it'll push the water away. And the water, see how the water went down? How the water went down, and then it comes back up on down the pipe. But see, you get a buildup right there for maybe a foot or two. So air leaks in water systems create dirty spots in your pipeline. Another place to look is dead ends. This is a wash system. The wash water comes in from the right, hits the pipeline and runs around. The back side of that plate right there is dirty because the water shoots by it so fast. There's no actual physical contact. So look at places like that. The pipeline on the left, it's the same on both sides of his barn. It's a little small double four. He takes that end down about once a week and hand cleans it because the water shoots in the back and doesn't wash the back of that pipe. The other one there on the right is up in Virginia, and I just started working this guy, but his counts always ran between 40 and 100,000. Never could, and it's a new dairy. Everything's good. It goes all the way around the dead end, and that's a air injector there on the end of it. And so one time I went up there and I tore it down. And it was about the third time I tore it down, but I found a little ball about that big. And it was hung in that joint right there. And so we cleaned it out. We trapped out his system 8 times before we got all the stuff out of his line. Had real hot water, it was sterile. But that ball came out of a fresh cow pail that he had that had a ball in the top to keep him from overflowing the fresh cow pail and getting bad milk in the line. And I asked him, he'd been missing that ball for 2 years. It'd been in that system that long. So anyhow, he was so tickled that we finally found something. And, I mean, this is a good modern dairy. It's just one of those mechanical things. In North Carolina, that on the left is a diverter. We have a lot of them in North Carolina. I didn't have many in Virginia or in Georgia, but most all systems have something like this. When you milk, there's a spring in here, and the spring pushes a plunger. I'll show you a picture next slide. And the plunger, when the plunger is forward, it makes all the wash water go the other direction. When you turn the vacuum on, when you milk, it sucks that plunger back and lets the milk come in from both directions. This is one that was broke. You see the clabbered milk around on it, and even back in the floor, there's a big piece back there. He started hosing it down before I could get a picture of it. We took it outside, took it apart, and the spring was broke in it, and that was all that was wrong with it. And I hope it's the next slide. Yeah. That was last fall. This slide was about a month ago. A guy about 5 miles from the other guy, their barns were built about the same time. He's got had the same broke spring, but his whole system was nasty, and that's inside his trap. I like to draw on people's equipment when it's dirty, and so when they come, I can show it to them. So that's what that little piece of equipment can do. And if you look right here, that arrow, this wasn't a real good picture either, but that's the wash line. That's the line that brings the wash water down to all of your jetta cups and your claws, and it goes through them into the system. And that's a blue barrel, but I got all that stuff out of that wash line at the end of it. People never look in there, but well, it was both sides of that barn, but my hands were just black. The chlorine had actually just eaten all those rubber parts up and washed it. And think about each one of those as it works its way down that line is stopping up a jetta cup. So you might have a claw that doesn't wash for a day or two, and then it moves to the next one till it all gets to the end. And I don't know, that's a rock. I don't even know how it got in there. But it'd surprise you. You don't always find stuff, but it's just a place to look. Tank washers, most of them either have a spray ball or they have the wand. Down here, sand is an issue in your water. And if you look in the tank, if you've got a spray ball and find a dirty spot, probably you need to get in there and take that ball down. It's probably got sand stopped up in some of the holes. The other thing that people don't think about on the wand right here is if it's not adjusted right, if it's too close to the floor, water will cover it up, so it can't blow water from underneath the water. And if it's too high, it will shoot over top the agitator. So if you're looking in a tank and the agitator's dirty and everything else except maybe some in the back corner's dirty, you need to measure that that wand. Most of them should be 2 3/4 inches from the bottom of the tip to the floor. So, and you can get an inch board and drill you a hole in it about with the bottom of the hole 2 3/4 inches, and you can stick it. You don't have to get down there with a ruler and try to measure. And so why does it change? When these pumps are new, you see it's got a grommet on the leg that's gone, which is maybe that thick, and over the years that wears out, so it drops 1/4 inch right there at the legs, and an inch there is like my shotgun shooting. You know, an inch here might be a foot out there, but an inch there could be an inch or two out on the end of that wand, so it might be shooting up. Or your inspector might have come by and said, you need to pour concrete under here because your gravel's short in your concrete. So you put too much and then you got it down too low. And then those things can slide on those legs too. The only reason I'm showing this slide is we're going to look inside that right there. This guy had 10 of these in his barn, and those are just takeoffs. But you look at this and you say, well, man, they're nasty. What are we going to do? But you got to think about what caused those to be nasty. And I invented this guy myself. That's the rubber guy. Rubber has memory. Think about it. If you squeeze rubber like a gasket and put it in a place, it's going to push back. And it'll do that for so long till it gets old, like the guy on the right. You know, and so he can't hold a tight seal, so it sucks air in and lets milk go in and out, and you can have high counts there. So just remember, rubber has a memory. That's the same with your inflations. But see, here's an old glass receiver, and see the milk that's on that old rig. I bet that was put in when that glass receiver was put in. You know, it's just hard. You probably take it out and break it. So you need to keep your rubber parts, your gaskets and all that in good shape so they do their job. Inflations get cracks in them. If you get a crack, it'll suck the milk up this milk tube and on up into your pulsator line. I've got another picture later on. People say, well, that's not a big deal, but I'll show you. And, you know, inflation life too. But rubber has a memory. It's only designed to be squeezed so many 100 times or 1,000,000 times or whatever. Foreign air supply. We have people that have air compressors and they hook them to right at their pump to pump the milk up and over and maybe through a plate cooler or through a tube cooler, because there can be quite a bit of milk in there, and there's no problem with that. Our girl up in Kentucky works a lot of Amish people. They milk in flat barns with buckets, and they have a thing called a Sputnik. I'd never seen one until I went up there. And it's just a big round stainless steel tank on wheels, and they pull it through the flat barn, and they pour their milk in it as they go around. And then when they get it full, they pull it into the tank, and they hook an air compressor to it, and it blows the milk over into the tank. And she called me one day and said, I can't find anything dirty on this farm. And we got around to talking about this thing. She said Sputnik, and I couldn't believe what she was talking about. But so we finally decided. She went in there one morning before they milked on an empty tank, got the first tank of the Sputnik and got a sample out of it. They blew it over with the air, and she got a sample out of the tank, and the one before was like 10,000, and the one after they blew it was 1,000,000, just from that nasty air supply blowing it over. So just that air supply, you've got to keep the air compressor clean and dry and keep good filters on it. This is my favorite. I do this everywhere I go. If I got one of you up here and I dissected you and cut out all your organs and laid them on a table here and weighed them, which would be the heaviest organ? Anybody got an answer? It's your skin. So think about that as you go to a farm looking for a problem, and say it's up in the million PI count. You think, man, I'll find a whole bucket full of old clabbered milk. Well, what if you just find a little film in the whole system? That's more surface area than a bucket full of clabbered milk. So just always remember that when you're looking for high counts. It doesn't have to be a big wad or something. It can be real thin and be in the whole system. Like a swing line. When water leaves the vat, it's the hottest. It circulates, and when it comes back, it's the coldest. And if you let your water in your water cycle get below 120, it'll redeposit fat on that swing line. That'll be a little film. When you look at it, hold it up to a light, it'll look dull, black looking, instead of shiny, bright stainless steel color. This is just some things I've encountered. If you're one of these big dairies, you're down for 20 minutes, really before you start back, you know, if you had a problem with a herd coming in or a cow down or whatever, you should really rinse the cycle and sanitize before you crank up again. Because you think about that line is sitting there with 98-degree milk in it for 20 minutes or maybe longer, but anyhow, from the numbers of how it multiplies, that's just a little point I like to throw out. You can get high PI counts from a hauler leaving milk and then you milking on it again. That's the same as if you didn't wash your milk tank. And don't let him get a sample out of your valve. None of them do that stuff. If you go along, you have a good count, then you have bad counts, and another bad count, then you have another good count, and you didn't do anything. Sometimes, if you've got real good hot water, your water will sterilize a buildup in your line, like we showed with that pipeline a while ago. And if it's sterilized and we got a sample, and it's good, the next time when we get a sample, a chunk of that may have fell off. And so that's one of the reasons that you can have good and bad samples one after another. A lot of other reasons, but that's one most people don't want to think about, but it's part of it. If you have two milk tanks and one's clean, if one's high and one's good, then it's in that one tank. If they're both bad, then you should go look in the pipeline. Some people up in the mountains use Clorox instead of dairy sanitizer. Dairy sanitizers, they say, well, they got the same chlorine percentage in them. Laundry chlorines have buffers in them. If you spill them on your pants, they'll put a white spot on your pants. If you spill dairy chlorine, you'll have a hole in your pants next day. If you're going to use one of these, you should run it for 12 to 15 minutes. You've got to beat the buffers out of it before the chlorine will actually kill the bacteria. So if you're sanitizing with something like that and only run it 5 minutes, you're just wasting your time. This was an interesting dairy. This is one that had one last time to be shipped before they threw him out of the last plant. He'd been thrown out of 3 or 4 plants with high PI and LP counts, and the cows were in a real bad environment. But they got through milking. They had a plate cooler. They ran their rinse cycle. They put a new filter in, and then they washed. And then about an hour later, they were going to come back and start milking, and they were going to use that filter right there to start back with. Would you like to drink their milk? They had a lot of other problems, but and even if your filter doesn't look like that, you think about that filter is still wet from when you use it. If you're down for an hour or two before you start milking, bacteria is going to grow all over that filter, even if it looks like it's clean. Take it out and change it and put a new one in before you start milking again. This this is a filter. I took the picture on the left, but I made a close-up. It was so nasty it blew a hole in it. And I actually cut it open, and the inside of it was just as dirty as the outside. And I will also add, but I got some more pictures where this filter came from later on. Filters should never be used more than 4 hours. Even if you do a great job of cleaning, you should stop and change them every 4 hours. They just accumulate bacteria. And once you get to 4 hours, you're adding that back to your milk. And you can do a good job. That's 800 cows. My good dairy over in South Carolina, we were looking for black specks in a milk tank. We were running these filters, and that's 800 cows milk come off his farm. But there was actually one little piece of feed on it, but it fell off right as I was taking the picture. Other things are mechanical breakdowns. The washing center on the right, a hose is not stuck down in there so it can suck the soap up. That causes problems. The barrel on the left picture on the very left, is chlorine, and you see the little pipe is just stuck in the hole in the top of it, right there. It's not tight. Chlorine is a gas, it'll leach out. And so by the time he gets to the bottom of this barrel, his chlorine's not working good. Another thing about chlorine in these drums, don't leave them where the sun can hit them. If you get a shipment of them, don't leave them out where the sun will get them. The sun will go through these drums and leach out your chlorine out of it. And this little thing, there's a plate cooler's got a leak in it. If milk come out, other stuff can go back in. This was an unusual one, a zero tank. Zero tanks wash with those agitator paddles. And you turn them on real slow while you're milking, but then when you wash, you put your chemicals and water in, and they spin real fast, and they just throw the water all over the tank. And you know, we talked about surface area. Those paddles are turned like this. So as it cuts through that water real fast, the water's hitting and going up. The back side of those paddles were dirty because the water never hit the back side. So that's just another place that was dirty. But we looked at this one for months, and finally the farmer got down on the ground and looked through the drain hole in it, and he could see buildup on the back of that agitator. And then he got in and cleaned it. This is just another receiver. That ball's supposed to be white in that trap. This is the last trap before it gets to your vacuum pump. There's something sitting on that lid, but those lids, you just pick them up and there's a screen in there. If you've got milk all the way to here, you've got milk all the way back through your vacuum tank, all the way back into the trap in the barn. That's the reserve tank. Most of these are upstairs in the dairies. This one was on the back of this guy's barn, but I got a good picture of it. It drains from the right side. That pipe coming out over there drains, and sometimes these things, they set them on wood and they'll settle. So if it settles away from the drain, any water that it gets in there will stay in there. It'll never come out. And occasionally you might get milk up in there. If your milk pump quit and it got by your ball and your trap, it'll get on up there. So always look at these and make sure they're draining. You know, I said a while ago about inflation's breaking. That's a pulsator line up in Virginia in a flat barn. That's a 4-inch PVC pipe. We drug that booger out of there on the floor. It's about that long, and it was petrified. And that one was white. I found one Monday down here in Florida that was like 3 feet of the pipe stopped up, and it was all black. Now I couldn't get a picture of it. Well, it wouldn't have been in here anyhow. So anyhow, that's been in there for years. So it does get in there. If you have a busted inflation, you're going to get milk up in that thing, unless you catch it real quick. This is not a real good picture, but this is a guy that doesn't have grates in his floor, and that cow had done her business, and I took the picture here because right before I took the picture, that machine fell off and was just full of that stuff. So you can judge that by yourself, but you need to have grates, in my opinion. Now, I've got this picture mainly for when I give this show up north. They don't believe y'all got swimming pools for your cows. And here's a cow that went through there, and you can see the water line on her. See how clean? She's clean from there down. This is the dairy that I showed you that filter that had a hole in it. So I don't know how good it still goes back to how good a job your employees do on prepping those cows. This is another little trick here. This is my boss. He had this dairy he had that problem on, and we took the back corner of the pipeline off, and you can't get your head in there. So we undid the other end of the barn. I shined a light in there and gave him a mirror, and he could hold a mirror with the light shining down the pipe and see if his pipe was clean, and it wasn't. It was dirty. His air injector wasn't working right. So That's about it. Got questions?
Questions? Well, lunch is coming up, but.
Most days are tomorrow.